Hi everybody, welcome to the Kentucky 4-H Virtual Experience. Today we're going to concentrate on SET or Science, Engineering, and Technology programs. My name is Tori Earle and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky College of Agriculture, Food and Environment Cooperative Extension Service. Our activity we're going to do today is from the Electric Excitement 4-H curriculum and from the Magic of Electricity, which is the first level book. The activity is called Bright Lights. And in this activity you're going to learn more about what a circuit is, which is a complete circle that electricity has to flow through in order to do work. You're going to learn a little bit about a power source. You're going to learn about conductors and insulators, and you're going to learn a little bit about a load or an object that will show electricity is doing work. Now there's some things you're going to have to gather before you start the activity today so you'll be successful and you'll have things to work with. You're going to need 1 or 2 either C or D size batteries rated at 1.5 volts each. You're going to need a small flashlight bulb, which is rated at 3 volts or above, and you're going to need a piece of aluminum foil. Now, our aluminum foil is going to serve as our conductor, because a conductor is a piece of metal, and some of the more common conductors are copper and aluminum, and you can also use in higher end components either silver or gold serve as conductors of electricity. An insulator is a material that electricity will not flow through, and insulators commonly can be plastic or styrofoam, cloth or paper, other materials like that electricity will not flow through. In doing our activity today, hopefully you're going to also learn a little bit about problem solving and thinking critically and how to work through a situation that you may not always have the instructions for. Now, let's get started with our activity. As we start our Bright Lights activity today, you want to make sure that you have all the supplies that were mentioned in the intro handy and able to be used. 1 or 2 D or C size batteries, a small flashlight bulb rated for 3 volts, and a piece of aluminum foil. As we mentioned in the intro, electricity has to have 2 things to make a circuit. It has to have a power source and it has to have a conductor. But if you want to see electricity work, you have to have a third thing, which is an object for it to show work on, which would be considered a load. As you look at your battery, you'll see that it has a positive on one end and the other end is considered negative. And in order for electricity to work in a circuit, the electricity in direct current, which is what batteries are, has to flow from the positive to the negative. To see it work, you have to have the load in between. So our challenge today is to get the electricity to flow from the positive through the load and back to the negative. To do that, we're going to have to use our conductor, which is our aluminum foil. Now, you may try several ways to do this, but I'm going to show you one that will make you pretty successful, and then you may want to try to get creative. Now, I will do a warning. Do not connect your conductor, your aluminum foil, directly from the negative of the battery to the positive. The electricity will flow and it will do work, but you won't be able to see the work. You'll probably be able to feel it because it will be like a little heater and it will get warm. So please don't do that without putting the load in. On your flashlight bulb itself, there's a small button on the bottom that you can see there's probably either a black or a white piece of plastic around. Plastic serves as an insulator, which is a material that electricity will not flow through. The button itself is metal, and the casing around the bulb that holds it all together is metal. Metal is a conductor, or a material that electricity will flow through. So the idea is, the button on the bottom is positive. The casing around the outside is negative. What we have to do is connect those two. We can set the positive on the positive pole of the battery, but electricity is still not flowing because it doesn't come from the negative to the negative. So what we can try to do is make that negative on the light bulb touch the negative on the bottom of the battery. And let's see what happens. We get a little bit of light. But I said these light bulbs are probably rated for 3 volts or maybe a little higher. And the voltage is what provides the power for the light. So let's take a second battery, touch the negative to the positive on the first battery, and then touch the light bulb to the positive on both batteries. And we get a lot more light because we have doubled the voltage. Each one of these batteries is rated at 1.5 volts. So 1.5 plus 1.5 equals 3 volts, which doubles the amount of electricity that's going into our light bulb. As you would experiment with this, you might get a little longer piece of aluminum foil, get a third battery. What do you predict will happen? Try it and see, and then you can report back and let us know what you found out. As we finished up our Bright Lights activity today, what were some things that you learned? Did you have to problem solve? Did you have to think creatively in order to figure out how to make the flashlight bulb light up? Did you learn how electricity flows in a circuit and what the components were to that circuit to help the electricity flow? Keep all these things in mind, because as you would do this, this could be the beginning of your 4-H electric project. In the coming weeks, we're going to go through a few more of the key things that you would need to know in order to do an electric project for Kentucky 4-H. Also, I'm going to show you a few things that could lead to building a state fair project in the 4-H electric project. I'm not going to show you exactly what a state fair project looks like, but we are going to show you some of the skills you would need in order to develop your own state 4-H fair project for the electric project. Thank you for joining me today for the Kentucky 4-H virtual experience focused on science, engineering, and technology. For more information about the 4-H SET program, please check out your local University of Kentucky Cooperative Extension Service.